I mean, on YouTube. Check, check. Check, 1, 2. Can anybody make sure we are online? Because the last time we did all the broadcasting without any voice, which is too bad. All right, so I want to make sure everything recorded properly. Check, check. So where is my channel? YouTube. And if you go to Meetup for today, there's a link for the YouTube. I think I just posted to my Facebook.
It's working.
It's working with the voice?
Yep.
Okay, cool. All right. So let's get started. So as I said, free Wi-Fi, and we have the free drinks and the restaurant outside, pizza and sushi is coming. And today we have 2 international guests, and this is our first time to combine the event of the Azure Meetup and .NET Developer Meetup, meaning you can have both .NET Developer content and Azure content. But before starting, let me just sharing some information from Microsoft side. All right, so as you may or may not know, we had a big event last month, right? Because this is August already, right? Last month, so Inspire. How many of you see the core note? All right, not so many. So can we just play the core note for 2 hours now? So we changed the name from Keynote to core note, and in this Inspire, we have 2 core notes. One core note for the business, another core note for the developer. And the second one actually having the Satya. So if you are like Satya, go ahead for watch the second one. Another big event we had last month is a Business Application Summit. Basically, it means Dynamics in Microsoft context. So if you are a Dynamics developer, like Common Data Service, POPs, Flow, Power BI, just try to search Bing search or Google search or Bingo search the Microsoft Business Application Summit. And you can see the core note and all the session is available as on demand. So you can kill your time, either Netflix or the tech sessions. And this week, just finished today, right? Google has a big event, Google Next. Is it I/O or Next? Next. Google Next has been just done. And the first speaker here is a very special guest from that event. So he's coming from UK for this event. And he just speak at the Google Next as well. So your primary reason to come in here for this event, right?
For the meetup.
For the meetup. All right. So could you introduce yourself?
Yes. Hello, everyone. My name is Mete. I'm a developer advocate at Google based in London. And yes, I came here for Google Next. And since I was here, I decided to speak at the .NET Meetup as well. That's what I always try to do when I go to places. I think I was here last September, wasn't I?
Yeah.
Last September at the same event, I was here again. I don't know if I know you were here. But yeah, should I start speaking about the topic? Or
Could you share your screen?
Yeah. I think I'm in the Hangout, you mean?
Yeah, you already hung out, and I just share your picture now. So everybody's seeing your picture in the internet.
Okay.
And please unmute. And could you don't have to turn on your camera, but you want to share your screen.
Let's see. Okay.
And yes, we can see that. Cool.
Very good. Yeah. Okay. All right. So I'm going to talk about Knative today. But before I start, I want to ask people whether they use Kubernetes. Anyone here uses Kubernetes? Okay. So this session is basically for people who heard about Kubernetes, or they maybe use Kubernetes, and maybe they heard about Knative, but they don't know what it is. So it's kind of like an introduction to Knative. This stuff, yes. This stuff that I'm going to show, it's on Google Cloud, but you can think of it as Azure as well if you want, because Knative runs on Kubernetes, and Azure has Kubernetes as well. So everything I'm going to show today, it will apply to Azure as well. There's nothing special about Knative on Google Cloud. All right. So what is Knative? Knative, it's a Kubernetes-based open source building blocks for serverless. By the way, how much time I have so I can pace myself? 30 minutes?
As much as you want.
As much as I want. Okay, great. Then I will be here for 2 hours. And this sentence, if you know anything about Kubernetes, it doesn't make sense because there is nothing serverless about Kubernetes. Like when you set up Kubernetes yourself, you need to set up physical machines, you need to think about them. When you run in the cloud, you have nodes, which are virtual machines, you still need to think about them. So there's nothing serverless about it. But that's the whole point of Knative, right? Like it tries to give you the building blocks so that you can treat Kubernetes as a serverless platform. And hopefully by the end of this talk, you'll see what I mean by that. Now the project itself, it's an open source project on GitHub. It's started by Google, and it actually has some hints of App Engine. I don't know if any of you use Google's App Engine, but in App Engine, there's things like versioning and traffic splitting. So all those concepts, they kind of made their way into Knative, but now it's open source. And then other companies now, Red Hat, IBM, and others, they're kind of contributing to it. So it's an open source project. It's not Google anymore. And there's three parts to Knative: serving, eventing, and build. So these three components, they kind of make Knative. So that's what I will explain today. So the Knative stack kind of looks like this. First, you will have Kubernetes as the base platform. Then on top of that, you have gateway. So the Knative project itself, it doesn't handle the networking details. So all the traffic management and the traffic to your containers, it's handled by a gateway. And usually that gateway is Istio, which is another open source project. But in the latest version of Knative, we also added support for another gateway called Glue. I haven't used Glue. Anyone here use Glue? Yeah, I'm yet to meet someone who actually used Glue, but apparently it's a lightweight gateway, and that's why they added support for it. So Istio, even though it's great, it's kind of a little bit heavyweight for what you want to do, and now there's support for Glue, but if you use Glue, then Knative eventing doesn't work for that yet. So you need to keep that in mind. But okay, either way, you have the Kubernetes and you have the gateway. On top of that, you install Knative. There's three different components, as I mentioned. You can install them one by one, or you can install them all at once. You can pick and choose. And the idea is that once you have the Knative foundation, then there's other products that are being built on top for developer experience. So on Google Cloud, there's something called Google Cloud Run, which is the managed version of Knative. It makes it, and I'll show you a demo of that as well. It makes it really easy, basically, to use Knative. With a single command, you can deploy a container, and it just works without having to think about any clusters or Kubernetes or anything like that. And there's other products from other companies as well that are being built. Maybe there will be something from Microsoft as well, I don't know. But the idea is that, you can use Knative as it is if you want, and that's what I'm going to show today, like Knative open source. But if you're in a cloud, you would probably want to use a managed version, so you don't have to manage it yourself. All right, so how do you use Knative? Well, first you need a Kubernetes cluster. And depending on which cloud you are, there's different ways of getting a cluster. But in Google Cloud, it's basically a single gcloud command tool. So you just say gcloud, create my cluster, this is my name of my cluster. Then you say add-ons, and then you specify Istio. So by specifying Istio, you're basically saying that I want a Kubernetes cluster, and I want Istio installed on top of it. So you use Istio by default. Then you specify the machine types and number of machines and the zone and all that kind of stuff. So this is just a typical Kubernetes cluster with Istio. Then you create a cluster role binding. This enables Istio to manage the traffic in your cluster. So once you have these dependencies, then you can install Knative. So to install Knative, you go to the version of Knative you want to install. So in this case, I'm installing 0.7.0, which is the latest one as of last week. And I'm just pointing to some YAML files. So I'm installing Knative serving, Knative build, and some monitoring stuff. So you pick and choose what you want, but this basically installs all of Knative for you. So at the end of this, what you're gonna have is that I'll show you. This is Google Cloud Console, and I already created a cluster. So this is a Kubernetes cluster for Knative 0.7. And I already got the Istio and everything. So let me just make sure that everything works. So Knative is just basically another number of pods running on Kubernetes cluster, but these pods, they go under separate namespaces. So for example, Knative serving pods, they go under Knative-serving. So let's just make sure that they're running. So let's make this a little bigger. So you can see that the pods are Knative serving eventing, same thing. So these are the eventing pods, and then Knative build. These are the Knative build pods, right? So all of them are up and running. Now let's first talk about Knative serving, and then we'll go through Knative eventing, and then eventually we'll wrap up with Knative build. So what is Knative serving? It basically enables you to deploy containers in a serverless way. And what I mean by serverless way is that you basically tell Knative, this is my container image. It's in Docker Hub or Google Container Registry or some other registry. And this is the configuration of my container. And then you just say deploy this, and then Knative takes care of the rest. So it deploys the container in a pod. It makes sure the pod is running. It configures the traffic to your pod so your pod can be accessible. And once your pod is running and is accessible, it sets up automatic scaling. So you have 0 to end scaling. So if no one uses your pod for 60 seconds, it scales down to 0. If people use it a lot, then it scales up to end that you define. You get configuration for your pod, and every time you change configuration, you get a new revision. So you have multiple revisions of your container. And then, since you have multiple revisions, you can do traffic splitting if you want between those revisions. So you can say, I want 50% of the traffic to go here, 50% to go there. So that's it in a nutshell. It gives you a really easy way of deploying containers, making sure that traffic goes to it, and then set some rules on that traffic. So the primitives of Knative is kind of like this. You have a service at the top level. So this is a Knative service. Don't confuse this with Kubernetes service. It's something separate. It's a Knative service. Then it has a configuration where you point to the image and some environment variables and things like that for your service. Then once you deploy your service and configuration, you get a revision in Knative, and Knative also creates a route to point to that revision. So all the traffic goes to that revision. Every time you change something about the configuration, it creates a new revision, and then it updates the route to point to that revision. So that happens automatically. But once you have multiple revisions, you can also change this route yourself manually, and you can do traffic splitting so that you can do complicated, A/B testing, stuff like that. So let's take a look at this quickly. So as I mentioned, or maybe I didn't mention yet, I have on GitHub a Knative tutorial that has the link to the presentation, and it has step-by-step instructions on how to set up Knative and how to go through it. So I have things for Knative serving, eventing, and build. I won't show all of this today because it will take forever, but I'll show bits and pieces of that so that you get an idea of how it works. So let's look at a Hello World example. So in this Hello World serving example, what I want to do is I want to take a look at what it takes to deploy a simple container using Knative. Now, first, what you need to do is you need to create a service. In this case, what I'm doing is I have a service, a Hello World service in C# and Python that basically, when it receives a request, it will just say hello with a version number. It's something very simple. So I create that, then I build an image and push it to, I build an image and I push it to Docker Hub, but you can push it to any public repository. Then I define a Knative service. So the first thing to realize is that the API version is a Knative API, so we're using Knative API. The kind is a service, it's a Knative service. The name is Hello World, the namespace where it's going to get installed is the default namespace. And then this is the configuration of my service. I'm pointing to my image on Docker Hub, and I'm also passing in some environment variables called target with the value B1. So we're going to read this and print it out, right? So this is all it takes basically to create a Knative service. You point to your container and pass in some variables. And to deploy this, it's a regular kubectl apply, and then you just deploy. So let's just do this. And then before we do that, let's just watch some things. So let's see. Yeah. So here, what I'm doing is that I'm watching Kubernetes pods, Knative services, Knative configuration, Knative revision, and Knative route. But as you can see, I have some pods running. These are some pods for some other demo that I'm going to show, but you can ignore that for now. Let's just deploy the Hello World service. Service v1. So the service is created, and then you'll see that immediately Knative creates a Hello World service, and then it creates Hello World pods. So the pod is running. It's a little bit hard to see, but so the pod is running, the service is there, the configuration is there, and then revision is there. So this is the first revision. So everything is already up and running by just applying this service. Now, how do you get to this service? As I mentioned, the traffic is managed by Istio. So you have to go through Istio to get to this pod, right? And the way to do that is that in Istio, there's something called Istio ingress that's the external IP of your cluster. So you need to find that Istio ingress gateway. So that's how you do that in Kubernetes. And then you need to curl it like this. So what we are doing here is that we are saying, okay, I want to curl this Istio ingress, but behind the same ingress, you can have multiple services. So I need to specify which service I want to talk to. So in this case, it's Hello World. And default is a namespace, and example.com is the example domain that's set up in Knative. So that's how you would do it by default if you haven't configured your domain. Now here I show how to configure your own domain if you want. So I won't bore you with the details, but what I did here is that I'm using something called nip.io. It's a dummy domain service where you can basically map things like this. So the ip.nip.io to an IP. So I use that as a dummy domain service for my Knative service. So I set that up, and then at the end of that, what you can do is you can basically curl your domain with your service name. So let's just make curl and see what happens. So once we do that, if everything works, then it says hello v1, so we can get to our service. Now, as I mentioned, every time you change your service, let's go here. Every time you change the configuration, it will create a new revision, right? So it will create a new revision, update the route to that revision. So let's do that. For example, in this second version of the service definition, let's just change one simple thing. Instead of having a variable v1, let's have v2 and see what happens. So come back here and apply service v2. Now I'm doing a configuration change. Now you see that immediately it created a new revision 2, and it updated the route to point to that revision. So if I do curl to the same URL, you see that it says hello v2. So it updated the service to the new configuration. If you want to change your code, it's the same way, except you need to do, let's say instead of saying hello, we want to say bye in our code. So we're just changing some code. You would build your Docker image, you will push it, and then you come to your service and you update your image from v1 to v3 and deploy again, and that will do a code update. So let's just do that quickly and see that it works. So service v3. And again, we should see here a new, it's not that visible, but a new revision is being created, and you can see that there's multiple pods that are running for different revisions. And if we do a curl again, now it says by v3, so we updated our code. Of course, you don't update code like this in production. Normally, what you would need to do is that you would deploy services, make sure that they work, and then you would gradually send traffic to it until you are sure that it works. So you want to do A/B testing or traffic splitting, things like that. And in Knative, that's kind of easy to do. So let me show you some examples of that. So in this traffic revision example, the first thing to notice is that when you look at your revisions in Knative, they have like random revision numbers when you deploy by default, right? But this is not useful for traffic splitting because you need to have names that you can refer to in your configuration. So first thing that you need to do is when you create your service, you can give your revisions a name. So if you specify metadata name and say hello world-v1, now this revision will have hello world-v1 as its name. Then in the traffic part of your service, you can refer to it. So in here we are saying that the current version with the revision name hello v1, which is this one, will get 100% of the traffic. And the latest version, if you deploy another version, it won't get any traffic. That's what we are saying here. So we are pinning to a version 1 of our service. So let's try that. Service v1 pinned. And what you're going to see is that this creates a new revision, and this revision here now has, it disappeared, but it basically has hello world v1 as the name. If it doesn't, yeah, it shows it here. So hello v1 as the name, and if we do a curl again, you will see that it says hello v1. So we pin to version 1. Now let's imagine that we have another version, version 4. So let's deploy that. And this version 4, instead of printing version 1, it will print version 4. And it will, you can't see it here, but basically we deployed another version. And let me show you the configuration here. So what we did here is that we deployed another version 4. That's just, we'll print version 4. And we are saying that the current version, the version 1, will get 100% of the traffic. And the latest version, which is this one, will get 0%. So what we did is that we deployed the latest version as a test, but it's not getting any of the traffic. And the previous version, version 1, is getting all the traffic. So that's how you would test a version without changing the traffic. And if we do a curl again, you see that it's v1. It's still pointing to the v1. But if I want to test out the latest version that I just deployed, I can come to the URL and just say latest dash, and this will point to version 4. So that way you can test version 4, and then once you're happy, you can change traffic splitting rules. So you can come here and then say, let's say you want to do 50%, 50%, you can come here and just change this from 100 to 50 and 50, and then you will have 50%. So that's how traffic splitting works in Knative serving. And you can also configure auto scaling. I won't show it here, but basically in this part of the tutorial, I show how you can deploy a service that kind of sleeps to simulate traffic, and then you can set auto scaling and see that it auto scales. So you can try this yourself if you want, but I just want to point out that the auto scaling by default is concurrency-based auto scaling, meaning each pod will get 100 requests before it scales up. But you can change that number if you want. So in this case, I'm changing it to 1. So after 1 request, it will scale up. And the type of auto scaling can also change. So you can change from concurrency-based auto scaling to CPU-based auto scaling if that's what you want. And you can change the minimum scale and the maximum scale. So by default, in Knative, minimum scale is 0, meaning if no one uses your pod, it will scale down to 0. But if you don't want that, because maybe the container takes a while to start up and you don't want cold starts, you can set minimum scale to 1, and with that, you will always have a pod running, no matter what. And of course, you should always set maximum scale to something so that you don't scale infinitely. So all of this is configurable, and you can even write your own auto scaling if you want, and you can plug that in here as well. So all of that is configurable. So that's it, and I show you how to do that, and then I show how to integrate with Twilio. So because Knative services are public services, you can integrate with anything you want. So this is just one example of that, but we'll skip it in the interest of time. And as I mentioned, on Google Cloud, there's something called Google Cloud Run. So what I showed right so far is Knative. So every time you have Kubernetes, whether it's on-prem or Google Cloud or Azure, all of this stuff will work. But if you're running on Google Cloud, there's something called Google Cloud Run, which is the fully managed version of Knative, or Google Cloud Run on GKE, which is GKE stands for Google Kubernetes Engine. So if you want to run Knative on Google Kubernetes Engine, you would use Google Cloud Run on that, right? So let me show you an example of that. So to run in Google Cloud Run, it's a new service, so it's only available in this regions: US Central, US East, Europe, and Asia as well. So you want to make sure that you're in that region. And then the second thing that you want to do is that Cloud Run doesn't support Docker Hub yet, but you can take the image and push it to Google Container Registry, which is kind of like Docker Hub, but it's tied to your project, Google Cloud Project. So what I'm doing here is that in this command, I am running this in where my Docker file is, and what this will do is that it will take my Docker file, move it to the cloud, and it will build that Docker image in the cloud, and it will save it in Google Container Registry, right? So I did all that, and then once you have your image in Google Container Registry, then you would just use this command to deploy that image to Cloud Run. So let me just copy this and come here and change my project ID. In Knative. I'm deploying my service. Now it's asking me, do you want to deploy on Kubernetes engine or do you want to deploy to fully managed version? I would say fully managed. And service name is hello world, yes. And now it's doing the same thing that I showed you. It's creating a revision and it's routing traffic to that revision. So it's the same thing, except the difference is that I didn't create a cluster, I didn't install Istio, I didn't install anything, right? I just said deploy this image and everything is done for me. So by the end of this, if you come to Google Cloud page and you go to Cloud Run, you will see that there's a service called Hello World. And then you get some metrics. I don't have any metrics because I just installed. You see some revisions. So this was deployed 2 days ago. You can see the logs, but basically, and you get a URL as well, so you don't have to configure domain yourself. You get a dummy domain as well. And if you click on it, it will still be the same. It says hello world. So the same thing, except I don't have to set up anything. It's just fully managed for me. So that's the way you would do it on Google Cloud. And I don't know why it didn't deploy. There must be an error. Oh, it's still working on it. Usually it takes like 5 seconds to deploy, but whenever you want to do a demo, it takes a while. Oh, error, yeah. There's some kind of error, but usually it's pretty quick, and then you can see here, like when it's updated, that it is deployed.
Yeah, because you're in
Yeah, maybe. All right, so let's get into serving. Now,
before going, I have a bunch of questions, if you don't mind.
Sure, yes.
All right. So I'm not quite sure how many people understand or do not understand in this room for this one, but I have a bunch of questions. And first of all, this is Kubernetes underneath anyway, right?
Yeah.
And from my understanding, Kubernetes has a deployment mechanism by default. So if you go to the YAML file, could you?
Oh, Knative, you mean?
Yeah, just YAML file for the Knative. But this is YAML file for Kubernetes anyway, right?
No, I mean, it's using Knative API, so let me show you.
I know. So that's the one confusion comes in. So because this is YAML, and when I look at this one, this is very similar to what the Kubernetes we are using for the Kubernetes, but the API version is usually just V1 for the default Kubernetes deployment engine, right?
No, I mean, the API points to Knative API,
and
right?
For this one, Knative API. So meaning if you install Kubernetes and Knative on top of it, Knative is take over the deployment engine on behalf of the, not on behalf of the other alternative deployment mechanism for Kubernetes, right?
Yes.
Okay, so if I just changing this API version back to V1, it purely becomes just a normal Kubernetes deployment template.
Well, you need to use
with several, options.
Well, actually, that's a good point, because if you look at my latest, I actually just blogged about this, and I'll point you to that. Stories.
Yeah, because I want to know which part Kubernetes take care, which part Knative take care.
Yeah, so here I say migrating from Kubernetes deployment to Knative serving, and what I do is I show this is Knative service. This is how you would define it, right? And I said, okay, how can we do the same thing with Kubernetes deployments, right? And then the way you do that is basically you define deployment, Now, the API version is just pure Kubernetes here. It's not Knative, and it's deployment. Then you need to create a Knative Kubernetes service to expose it.
Yeah.
And then if you're on Istio, you need to create an Istio gateway to enable traffic, and then Istio virtual service to connect it, and then it will work. So basically, 1, 2, 3, 4 YAML files you had to define. Then in Knative, you just define this, and it does that basically.
Right. Okay, that's quite makes sense. So basically, for the Kubernetes, you have to create a bunch of stuff like the deployment service,
service, yeah, exactly.
Yeah, but now by using this, the Knative one with the deployment, is this the deployment or the service?
This is Knative service.
Knative service.
Yeah.
So by using the servicing, you can have very simple way to deploy your service, right?
Exactly.
But at the end, it is just a container, right?
Yeah, it's just a Kubernetes pod. Yeah.
Kubernetes pod running container on top of the Kubernetes, but you can simplify deployment with rich feature like traffic splitting.
Exactly. So not only you are simplifying the way you deploy it, but you also get on top of that automatic scaling, and you also get versions and traffic splitting.
Right, because from understanding, you can do the auto scaling by using the pure Kubernetes as well, right?
Yeah, you can. But again, I didn't show it here, but
you have to do so many things.
Exactly. Like
this is simplify.
Yeah.
Right. Is it kind of Helm competitive?
I mean, Helm is another way of doing this. Yeah, you could use Helm to automate all of this, but you're doing this at the API level. So so basically, Knative is giving you a higher level API to work with.
Okay, so for the people who do not know Helm is more like the helper tools to make it simple, but they're using the Kubernetes API, right?
Yeah.
This is kind of the Knative API.
Right. So it's like a higher level API that's
built
on top of Knative. Sorry, Kubernetes.
And another question is, I just have one other question. Go back to the console, please. Google Console.
Google Console.
Yeah. And this Cloud Run. So this Cloud Run is something we don't have to care about Kubernetes. We just put the pod and it's running, done.
Yeah, I mean, you just define your image that you want to deploy. So you just point your image and that's it. Underlyingly, under the covers, there's not even Kubernetes here.
Okay, so this is supposed to be the Azure Container Instance for the Azure. So you don't have to care about the underlying system. You just specify which image you want to run.
Right.
That's it.
Yes.
Okay, sounds good.
Yeah.
Thank you.
Yep. Any other questions before we continue?
Are we good?
Very good. All right.
We have sushi.
All right. Shall I continue? Okay. All right. So that was Knative serving. The second part is Knative eventing. So in a really simplistic way, Knative eventing basically allows you to connect event sources to event consumers with some kind of flow in the middle. That's all there is to it. The event consumers are usually Knative services, and the event sources can be a lot of different things. So this is some of them. This is not the full list. The full list is at this link, but you can listen things like, Apache Kafka messages. You can listen Google Cloud PubSub messages. You can listen storage events. You can listen Kubernetes events. So you can listen a bunch of different kinds of events and just feed them into Knative and then process them. And the way it works is that in Knative eventing, there is this things called sources. So these are the things that are reading the external messages, whatever you're trying to read. And then these sources will pass those messages to broker. Every namespace will typically have a single broker that will receive the messages. That broker will pass the messages to Knative services. But before it does that, it passes them through something called triggers. These triggers, they kind of do the connection between broker and the service, but they also have very simple filtering as well. So if this service, for example, doesn't care about any other messages but blue messages, then it can filter them in trigger, right? So that's the way it works. And I should also mention that the Knative events, so Knative can listen to a bunch of different kinds of events, but once they are in Knative's system, they get converted into cloud events. Cloud events, they are open source CNCF definition of events. So the cloud event will have some metadata about the event, so the ID and the time and stuff like that. but the data field will have the actual payload that you have. So in this case, for example, a GitHub event will have a cloud event with the data, with the actual GitHub event, and then your broker will see cloud events from then on. So you're dealing with cloud events in Knative. And I show an example of this. Maybe I'll show this as well. So what I am trying to do here is that I'm trying to connect Google Cloud Storage events to Google Cloud Vision API using Knative eventing in the middle. So the way this works is that when a user saves an image to a storage bucket, that bucket triggers a message to Google Cloud PubSub, which is a public subscribe messaging framework, to a topic. Then I make Knative eventing listen to the topic, so it listens to those changes. And then once it gets the message, it passes that message to Knative service. And the Knative service gets that message and says, okay, let me call the Vision API, which is a machine learning API in Google Cloud, and analyze what that image that's been saved, and it extracts labels out of that. So I set this pipeline, and this Knative part in the middle, I mean, everything is running in Google Cloud, but this Knative part can be anywhere, really. You can even run it in Azure if you want, because it's just anywhere that you have Kubernetes, it will run. So to set something like this, let me show you some of the steps. So let's go to my tutorial. So I have a Hello World eventing and a translation API example, but we'll skip those. But the Vision API, first, you need to create a handler that will handle the code. So let me show you the C# one, since we're in the .NET Meetup. So I create a dummy handler, but I'm just reading what's being passed in, but then there's nothing special here. But first, what we need to do is we're going to receive cloud events, right? As I mentioned, everything gets converted into cloud events. So I'm using the Knative's cloud event package, and then I receive the content, and I basically deserialize that into a cloud event. Once I have the cloud event, then cloud event can have multiple types of events. But when you save an image to Google Cloud Storage bucket, the type of the event is object finalized. So I just check for the event type, and if it's not that, then I just ignore it. But if it's the object finalized event type, then from the cloud event, I extract the URL of the image, because the cloud event has the URL of the image. And then I create a Vision client. So this is the client that I can use to talk to Google Cloud's Vision API. And then I just say detect labels async. So this basically says, go to this storage URL and extract labels out of this image using machine learning. And I'm asking 10 maximum results, because I don't care more than 10 results. So I will get these labels back from Vision API. These labels will have scores, because depending on how confident it is, it will have some scores. And I order them by scores, and I just log them out, right? So that's what I do here. I create a Docker image out of that. And just like before, I push the image, I build the image, I push the image, then I create a trigger.yaml file. So this trigger.yaml file has two purposes. The first one is Knative service. So this is just like before, I create the Knative service that will receive the messages. And I also create a trigger. This trigger makes the connection from the broker to my service. So I'm basically just saying, when you receive messages, send it to this Vision service that I defined here. And I'm not doing any filtering here. So any kind of message that comes through my system will be sent to my service. Yeah, that's it really. So let's just take a look at this. First, what I need to do is, if I do kubectl get, I need to set a source GCP PubSub. It's hard to type with one hand. So I need to set a source to listen for messages. So this GCP PubSub source listens for Google Cloud PubSub messages. So it's already set up. And I need to also have a broker in my namespace. And I set that up as well. And by the way, that's why I have this pods here, right? These two pods are the broker pods that are waiting for messages in the namespace. And this PubSub one is the one that's actually receiving messages from outside. So they're already set up. And now what I need to do is I need to go to eventing, Vision, And in here, I have a trigger. So let's just apply this. Now this creates a service and a trigger. And let me do kubectl get pods. Oh, sorry. Let me put this down for a second. So you can see that the vision pod is running. And let's look at the logs of this. So I will just copy the command. So I'm looking at the logs of this pod. And you'll see that it's just gonna wait. It's just waiting on port 8080. So it's just waiting for a message to start arrive. Now to trigger this, what we're gonna do is let's go to Google Cloud Console. And in here, this is Google Cloud Storage. And I created a Knative bucket. So this is the place where I can save images. And I already have an image. So let me upload another image. Eventing pictures. So this is an image of myself. Now, once I upload this, it will go to the bucket. The bucket will trigger a pops-up message. The message will go to a topic. Knative eventing will read that message, pass it to Knative service. The service will make a call to Vision API. And if everything worked, you can see that in the logs, our service got this cloud event with ID and data. So data is the part that actually has the information we want. And we extracted the location of the image and we made a call to Vision API. And the Vision API is saying that this is a guy with a forehead, chin, facial hair, beard, and all that kind of stuff. So I mean, nothing exciting, but at least like this shows that you can connect different things together with Knative eventing in the middle. So that's the key thing here. All right. And yeah, I think I should probably wrap up. The last part that I want to show is Knative build.
Sorry for the going to the period. I have a question for, could you go back one slide? Yeah, so for this one, by the way, this is very nice. So Cloud PubSub, can we just skip in Cloud PubSub and put in the Cloud Storage event directly to the Knative eventing? It sounds like we have two PubSub.
Yeah, I mean, you could do that, I guess. I mean, the thing is, yeah, you could do that.
I thought that the Knative eventing is PubSub on Kubernetes.
No, I mean, Knative eventing can listen PubSub.
Okay.
So it can listen PubSub events. And what I did in this case is that you can also configure Cloud Storage to emit PubSub messages, right? So I configured this so that when you save something, it sends a PubSub message, and then Knative eventing can listen those messages. So that's what I did here. But Knative eventing also has a way to listen Cloud Storage events. So I think you could have skipped the PubSub in the middle as well. I think it could have worked, but I didn't set it up that way.
Right. On the other hand, we have the Knative serving the pod and the application behind, right?
Yeah.
And can application directly get in the data from PubSub?
No, I mean it has to go through Knative eventing. Yeah.
And why is that?
Because this serving, it can only get like HTTP calls. It doesn't know how to read, say, like PubSub messages.
So PubSub is not HTTP.
No, I mean something has to call this on HTTP for it to know that.
So because it's not pulling.
It's not pulling, yeah. So this is the eventing is the one that's actually receiving the messages, yeah.
The PubSub has the capability to correct something whenever they receive something.
Yeah, you can do pushes from PubSub if you want. So technically, if you set this up so that it's like push-based, and if you specify a Knative serving endpoint, then this should be able to push it to here if you want. But in this case, the way I set it up is basically Knative eventing to pull the messages.
Okay, the one that is easier, and the two, because you can convert the Google Cloud specific event messaging to the Cloud Native message, right?
Yeah, I mean, yeah. Once this message ends up in Knative, they end up becoming cloud events. Then you can handle them in a generic way, yes.
All right, and for the people who love Microsoft like me, the Cloud Storage there is Azure Storage, and the PubSub there is Event Hub,
And the Knative with Knative, and Knative with Knative, and the Cloud Vision API is coordinated vision. Right? So you can map up pretty much everything. Okay, that makes sense. Thank you. And another quick question is if you go back to the shell, and every time you show in the shell of the pod, I see the pod keep decreasing because you had hello world v1, 2, 3 before, right? And everything going.
Yeah, I mean,
it's going because you set it all scaled down to 0.
Exactly. So you see that the pods that all the pods that are running, they're event pods. There's no Knative service pods because they scale down to 0.
Ah, that's nice.
Yeah. But if you do get kubectl get Knative service, you'll see that there should be a service. So there's 2 services actually, hello world and vision.
Right.
They're still there. It just they scale down. So if you hit their URLs, they will scale up and they will start serving.
So auto scale working here.
Yeah, cool. All right. Knative build. So everything I showed so far, it requires you to have a container image in a public repository, right? But how do you get your image, your code in a public repository, right? That's what Knative build is for. So what Knative build enables you to do is it enables you to go from your source code to a container image on a repository. And this can be Docker Hub, this can be Google Container Registry, it can be Azure's registry, it can be anywhere public. And the primitives for the Knative build is that you first have a build, which is basically one or more steps that you define that gets executed. From the build, you can create a template so that you can use it from multiple builds, or you can install other people's templates into your build. You have builders for building different things, including containers, and you have service accounts to authenticate with things like Docker Hub. So these are kind of like the main building blocks of Knative build. And just to show you an example, for example, in Hello World build, I built an image and push it to Google Container Registry. So again, the way you do that is that you define a YAML file, the kind is a build, then you point to your source code. In this case, I'm pointing to my tutorial, and then you define the steps that you want. In this case, I have a single step, build and push. I'm using a project called Kaniko, which is an open source project to build container images. And I pass in an argument Docker file, so I'm pointing to my Docker file, and the destination is gcr.io. So this is my Google Container Registry. So I'm basically saying, build my image using this, and then push it to Google Container Registry. That's it. And then once I apply this, and actually let's just build one. Let me just show you one example here. Build, and then again, it's like kubectl apply, and let's say, oh no, I want to do build hello world GCR. So I'm just building that, and then if you look at the pods, now you'll see that there's a build pod, so it's being built in the pod. And then if I do get build, this will show me that there's a build that's been pending. So once it's done, it will be finished, and then you should see the build pod pushing your image to the container registry. So that's all there is to it. But the couple of other things that I want to show you is that if you want to push the Docker Hub, for example, you need to authenticate. And to do that is that you need to create a secret. It's a Kubernetes thing. You need to create a secret. And then you need to create a service account that points to that secret. And then when you design your build, you do it the same way, except you point to your service account that you want to authenticate with. And that's how you can authenticate with different things. And then the build templates allow you to install templates and use it in your builds. So in this case, for example, instead of defining Kaniko myself, I'm installing the build template for Kaniko. And then in my build steps, instead of pointing the steps myself, I just say I want to use this template, and this is my image, and that's it. So you can have more structure in your builds. And very last thing I want to show is that anyone knows build packs or use build packs? So build pack, it's an open source project to build Docker images from your code, right? I don't know you, but every time I need to create a Docker file myself, you can create a Docker file, but it's probably not as optimized as you think it is, and it's probably as not secure as you think it is, right? It's always really hard to get Docker files super optimized and secure. That's why there's BuildPack project that basically looks at your code and it tries to figure out what kind of code you have, and it tries to get you an optimized and secure Docker file. So there's a BuildPack template in Knative, so you can install it BuildPack template like this. And then once you have that, what you can do is that you can do a build. And in here, I'm pointing to some Java application. And this Java application, if you go to that Java application, there's no Docker file in this Java application, just a pure code. But it uses BuildPack template to kind of create the Docker file for me and then push it to gcr.io. So that way you can build images without having to deal with Docker file details. That's all I have. So if you want to learn more, this is the link with the slides and much more than I show you. Knative has a new webpage, knative.dev. And as I mentioned, if you want to run Knative on Google Cloud, you'll probably use Cloud Run. So that's the link for Cloud Run. Thanks for having me.
And as usual, I have a question.
Yeah.
All right, so the first two things make very sense, like servicing and eventing.
Yeah.
This build, do you have any reason behind why Knative is supporting the build? Because this is kind of building
Yes.
and creating the container, pushing to the container. Then you have to run another servicing to put the image back to the Kubernetes. Or what happens when you build that?
Yeah, I mean, the whole idea of Knative build is that, Knative service requires a container image, right?
Mm-hmm.
So how do you create a container image?
Mm-hmm.
So that's what build is for. Like how do you create and push it, and it tries to help for that problem.
So in the production, so do you guys recommending using the build in the production system when you're serving the service to the user? Because this build consuming the CPU, right?
It is, yeah. I mean, you
you
probably don't want to run the Knative build in the same cluster as your service.
Okay, so a separate cluster.
Yeah, separate cluster just for the build.
All right.
Yeah.
Can we provision kind of specific node to running the build in the same infrastructure, or do we have to have that separate?
I mean, in Kubernetes, you can have taints where you can say this kind of jobs can run this kind of nodes.
Taints, yeah.
Yeah, so you can do it that way, or you can do it I would do it in a completely separate cluster, to be honest.
Right. This sounds perfect for the lazy developer. They can do everything in one place, right?
Yeah.
This makes sense. Yeah. All right. Thank you. Do you guys have any question? And it's your time. Ask question. Not only for you, but for everybody else. All right. You guys are super cool, so that you understand everything. All right. And you need to leave, I guess, right?
I have to. Yeah. I would stay a little bit longer, but I have to leave.
All right. Yeah. So it's 8:14 right now. So we will resume from 8:25. And meanwhile, you have all the time with me if you have any question. But before doing that, please give him a big applause.
Thank you.
All right, we'll be back in 10 minutes, you two. Carl, could you check your setup here? Thank you. This is very interesting.
Yeah?
Yeah, I never seen that before. And this build pack sounds good.
Yeah. I mean, I really like that project anyway, and I was super happy when I saw that there's a template in Knative for it.
Right.
So that's why I added it to my tutorial as well, so people hear about it.
Right. And when you say about native event, cloud event,
yeah.
Is that Google stuff or the open source?
No, it's open source, CNCF.
Okay.
Yeah, it's based on CNCF, and
so it's kind of the event format for any cloud.
Cloud event is supported by all of the CNCF for like Microsoft Event Grid, for example, supports natively CNCF.
Okay. Which I supposed to know, but I didn't.
Oh, there's so many things to know.
Yeah,
so
that's why we are running the event like this, right? to try to catch up everything. So which one you need, Vijay? HDMI?
This one.
Mini display.
Or I can do a full HDMI as well.
Either one.
Sure.
Yeah.
Let's put it. Serverless should be around at the original, but you guys are taking the serverless into the next level, meaning if you don't mind serverless, between serverless.
Yeah. I mean, the definition of serverless.
All right, people. 20 more minutes. Yeah, so you need to unmute your microphone. Yeah. In the
Hangout as well.
Hangout.
Yeah. All right.
All right, friend. Meet to him. So please say goodbye to him. Goodbye, Neil. I'll see you next year. Yeah, so you're coming to the next Google Next or the next Google I/O? No, I/O. Next Google Next, right? Well, where is the next Google Next? All right, so we hope you enjoyed Japan stay, and I want you back again to explain everything. Yeah, right. Thanks for coming. All right, in a minute, we resume the session. And before doing that, please feel free to take food and drink outside and restroom. And the next one is our last session. Fortunately, we only have 2 sessions today. Right? That's good, right? Because if you prefer the shorter sessions with more speakers, let me know. But this time I decided just for 2 speakers. Because each speaker has great content anyway. Yeah. All right, so I think it's almost time. So I just have over my
favor.
So I pass in to display everyone. So can somebody double check if the YouTube actually broadcasting cars content right now? And did you unmute your microphone?
Let's see.
That I'm muted. Yep.
Am I unmuted?
Right. Right. That's confusing.
That's
Are you ready? Can you hear the sound?
Yeah.
Oh, okay.
all right. Cool. All right. Awesome. All right. Good evening. Hi. Konnichiwa.
Konnichiwa.
I have no idea about the other. I think started with the O, but I don't want to try.
Yeah.
So this is me. Couple of rules about myself. My name is Carlos. I come from Finland. I've been working with Andrew since 2009. Really well, likely, apparently as well. And I come from a company called Azure. We only do Azure. Obviously,
Nice.
we actually managed to put in more, really more than Lightron for the .NET domain. Yeah, I do a lot of security audits for different types of companies around the world, all the way from these kind of small startups who want to scale something big, up to these kind of large Fortune 500 corporations. And this is essentially one of my favorite types of calls, because this is not made out of the top. Essentially, this is me ranting on about my war stories, about different things that I've seen gone bad in different security stories or security audits or any sorts of projects that I've seen that I've come across related to Azure and security. And this isn't necessarily something that we are building something on serverless story or some sort of Kubernetes story. This is not necessarily something that we are building something to do on top of Azure, which is the thing that I mostly do, but this is also kind of a collection of things that having gone wrong already before I had my hands in it. So this is also this kind of I do talk a little bit about virtual machines and this kind of not so cloud native And yeah, if you can hear me on that, then just please throw something at me or shout out. That's why we have the podium. All right. So very quickly, what to expect. Some of different security notes. I have one slide for each, and then I have a couple of pre-recorded demos because that's how demos work. Essentially, some screenshot-based examples, and where you can fix those things or how you find if you have failed on that particular fail, if you have done that as well. And yeah, after that, it's really let's get started. So I think I have like half an hour of time. So I'm just going to go on and on and on until I run out of time. So this is this type of session that there isn't kind of start and some sort of confrontation or any sort of drama, and then the end. Then it's just a list of dictionary type of list of brands that might go wrong in your projects. And these are not in any particular order than what frustrates me the most. So this is not scientific. I haven't scanned all of my customers and seen that this is the number one failure. Not at all. This is something that frustrates me the most. And I want most of you to be mostly awake for the first parts, and that's the kind of prioritization on that. So the first one really is here. This one. We are talking about public Azure cloud. We are talking about public computers in the cloud, somewhere in this island, somewhere all the way, like 1/3 of the internet is scannable. Everything, all IP addresses on Azure are actually available nowadays. Nice Excel downloads that you can use to automate any of your scans. So if you have any sort of public endpoints, it's something that most likely you should have, because you cannot just physically walk from Microsoft data center. You have some sort of public endpoint there. So please protect it. And this can be HTTP, HTTPS. This could be mean RDP or SSH management type of port. And it's very, I would think this is a basic thing, but this is something I see way too often happening. And this is how we mitigate it. Every public IP address that you yourself provision or you yourself see as a resource on Azure, if you have a Azure App Service, if you have a resource called public IP address on Azure, anything like that, your alarm bells should ring and you should start doing something. You should mitigate it. If you're dealing with virtual machines, use those network security groups. If you are dealing with those network security groups, you might know that they're very not fun. So you might want to look at some services like Azure Security Centers. If you pay a little bit more extra, you can have this just-in-time access, and they actually turn those RDP ports on and off just when you need them. You can use services like Web Application Firewall. You can use services like on those platforms and service endpoints. We have different firewalls, quote unquote, that we can use there as well. Depends on our Azure service. There's not always much that we can do. It's a risk that we might have to take. And if you're using Secure DevOps Kit for Azure, AZSK, which is a free-to-use PowerShell tool that Microsoft IT uses to scan their Azure environments, this is the security control that you'll find appearing when you scan your environment. And I'm going to link to the AZSK later on as well. That this is something that keeps happening. This is the format that you'll see for each of those fails. And if you fail at that, this is what we see. So I have a list of 2 virtual machines giving me log data for Windows virtual machines giving me log data for 24 hours. And this is the results. This is something that I'm seeing. I'm actually querying for Windows event ID 4625, which is essentially fail, login, attempt. So these are 2 virtual machines. I haven't done anything. I just created on Azure, and they are up there for grabs. And during 24 hours, for those 2 virtual machines, we see that we actually have here over 3,000 different attempts. But no, Actually, these are 3,000 different usernames that have been attempted. So if you have a look at this, for example, the administrator over here has been tried over 22,000 times and so forth. There's different typings, different variations of administrator. There's Swedish administrator, and then there's user test aloha. Well, depends on when I run this time. I might find interesting things like different printer names like Xerox and Canon. All of those might start to appear in their first names, all that kind of stuff. So I have over 24 hours, two virtual machines. I haven't done anything to them, totally unprotected, totally, but they are patched. They are the latest, greatest available on the Azure Image Gallery. So I'm not spoiling the total number, but over 3,000 different usernames being attempted over here. And if you are using those default galleries, well, in this case, those default names over here are protected, but most likely not. This is just to showcase you that you might think that you might not be targeted, but on Azure, you will be targeted the moment you turn your services on. And the same applies for serverless types of workloads as well. You might not see all of that workload. It might be something that Microsoft protects you from without you knowing of until something hits the fan. Okay. Next up, another favorite of mine related to role-based access control. Now, this is not role-based access control. Everybody has the same role, right? So the default role that you have when you create your new Azure subscription is owner, and very often this happens that when a new person comes into the team, when you actually start using the service more, you get the same, you ask for the same permissions that the first one had. So everybody is an owner and in the subscription code. So everybody can invite anybody from any email address in, like Yahoo, anything, my personal email, anything can be, anyone can be invited in, and those people who are invited in, and if I give them also owner access, they can kick me out and they can create an infinite amount of costs. Actually, at the newly updated OWASP serverless security threats on the top 10 OWASP list for serverless, which is still on Meetup, one of the threats that they are looking at is denial of wallet. And this is how you do the denial of wallet for you. By inviting people in who can create infinite amount of costs and kick you out as well. So that's bad. Don't do it. The default access code should be the resource group for you, not the subscription. And really the default role should be the contributor, which is kernel name. You should use the contributor despite its verbal naming. It shouldn't be the owner, which is the default role if you don't make any contribution. If you want to give the same person access to create, and give any resources in Azure and also invite people in, then you can give them two different roles. You can give them the contributor role and the role called user access administrator. That's there, that's a built-in role. You don't have to give a single person this one role called the owner. For this specific failure that actually lets you know those users. Okay, and I kind of go on a little bit, but let's dig a little bit deeper on the next one, which is really the untrusted authentication provider. I mentioned that I can invite anybody in with any email address. By default, it's anyone from not just random Azure AD, not just some official email addresses from any account that is able to receive email for 24 hours. It's not even that they need to be able to log in, it's just that they need to be able to intercept those email addresses. You can use something called one-time password actually to get out of this that authentication as well. Because by default in Azure, we take away the trust, or we actually trust an external identity provider also. By default, it's a built-in Azure AD, which is infinitely better that you or I will build in the same amount of time that would actually take for me to create a new Azure AD tenant, which is a couple of seconds to 5 minutes in a demo scenario. So it is very good. We should trust it. There's a lot of greatness in having that external identity provider to trust. We don't want to have yet another password to store and to fail. But we should always know which identity provider specifically we are trusting. So it can be, by default, it can be anyone from a Microsoft account, so a live ID, a personal one, not the official Microsoft account. It can be any Azure Active Directory, not just your corporate own, but your scam version that looks like your corporate, let's say Microsoft e.onmicrosoft.com, for example, or any other fake Azure AD. It can be any Azure AD, it can be anyone with an email access. It can be Gmail, it can be pretty much anything. So we should always use trusted Azure AD for authentication purposes. When we invite people in, when we grant them this owner or contributor or user access administrator role, the first time when we are inviting them in, we should actually give them that privilege at the same time. We should first invite them to our Azure AD as a guest. Once they have successfully authenticated, because then we actually know which authentication method they chose. If some of you will send me an invite to Azure.com, you don't know if it's a Microsoft account, if it's a Azure AD account, if it's a Gmail account. You don't know until I sign in, right? So first let me sign in, and then give me some of those access privileges. There's a paid service of Azure AD called Privileged Identity Management, or PIM, that you can use to get automatic alerts from any of these kind of anomalies, to-be privileges, some new people joining in, etc., etc. If you are in an industry where you want to limit this a little bit more, because this is always a question of limit the agility of my development teams that are building new stuff, do I limit the use of the cloud, or do I want to focus on the security? So if necessary, you should go ahead and limit who can you invite at all. This wasn't available previously. A year ago, when if I would have given a talk on the same content, on the same specific slide, not all of those limitations would have been possible that we have now. Yes, it's the best case control ID. Here are the user settings for Azure AD that we can set, or that the whole Azure AD global administrator essentially can set. So someone in your company who has access to the Azure AD settings, maybe your Office 365 main admin, or maybe the first person who just created your Azure environment, depends on how well governed environment you have, has access to limit these settings for the whole corporation. You'll see that this is maybe something that we don't want to take away. Can we even invite guests at all? Sure, guests should be permitted, I would say. Admins and users in the guest inviter role can invite, so should we limit who is able to invite new guests, essentially build new trust with different email addresses or different domains, automatically create new federations, essentially. Can default members invite? By default, even guests can invite. So if I invite some of you to my environment, you can invite some new organization in and so forth. So that's on by default. You might want to think of maybe having some controls on that. And then we have the one-time passcode, which is not actually logging in, but just having the access to the email is enough for 24 hours to sign in. And very specifically on the bottom row over here, let's just go over, we have essentially the important ones. Allow invitations to send to any domain. This is the default. Then we have to a specific domain. So this is default this access list or whitelist, and then we have allow invitations only to specified domains. So deny invitation to specified as a deny list or blacklist, and then we have the allow invitation on the specific domains, which is the allow list. Yes. Mm-hmm. Yes. Don't go.
Yes. Can I block my Azure AD account being as guest to the
And would you mind repeating? Yes. So the question was, if I'm an Azure AD administrator who is tasked to controlling all the places, all the locations where my Azure AD users are signing in, and can I put in a control that limits, similarly to here, can I limit to where my users are getting invited?
Yeah,
right?
This is allowing
Yep.
non-Azure
Yes.
users to be able to test.
Mm-hmm.
Imagine I'm the equally configuring the
Mm-hmm.
I don't want my users to be added as guests to somebody else.
Yes. That's a good question. I don't have an answer for you. There's this kind of gray zone between where does it get boring in the Office 365 stuff and very, very interesting in Azure part of the Azure AD. I'm sure if you look at the cloud security, which is one of those monitoring tools that we use for Office 365, plus also Azure AD, you can at least get monitored alerted when your users are signing into new locations. Just accepting that invitation, not so sure.
Maybe I'll work around it.
Yeah. Yes. That is the question. So the thing is, you are actually just linking the object ID was not directed. So you are not passing any other personal information that your application is requesting that you
The system allows you to create application another company to log into your application.
Oh yes, and that's a little bit different part as well. Using that same identity, you have to log into an application. So that will be inside my Azure Active Directory. I will have a single object ID or a single service principal application, registered application, and that registered application has some sort of it's an API, it's an API ID, API key that has some sort of privileges to my Azure AD or even backend custom applications. And you user sign into that specific application ID, and you can add then another one and another one. That's not that part. Great question. And as always, let's take it offline. Let's move on. All right. What did I have next? Oh, there. As usual, perfectly on time. Number 4 is also one of those criteria that most people think they have in place. Most people have this in their, let's say, development practices, or most people think that they are not the ones who have this. But if you look at the biggest leagues available, if you look at the Capital One League, if you look at a couple of those other big leagues related to cloud storage in general, is the access keys for whichever cloud we have. In Azure case, we used to have exactly the same, only one master key that can do everything, and there's no by default, there's no login treat, and you can, there's no access control, there's no role-based access at all. If you have that key, you can delete everything on that storage, you can read everything, you can modify everything. You are not authenticated at all, you just have all the privileges. So this was the shared key that we used to have. So don't do that. Don't use the default master key, and don't use that at all. And because you already do, at least don't use it directly. Use it through some sort of key store, preferably an Azure Key Vault. So when you finally get caught that you are using that, how would you actually go ahead if it's a production level application? If it's something that is deployed to like conference room, physical machines, how would you go ahead and update those storage account keys when you need to, when you get caught this key is compromised, you need to somehow replace it. If you have hardcoded that in your application, then you need to physically walk here and deploy a new application, essentially. So at least store that somewhere where you can recycle that. That would be the key vault one first over there. But if you are building a new application, you don't need to think about these keys at all. If you're building something new and native to Azure, you don't need to think about any specific keys. You don't need to create any SSH tokens. If you just want to have your, let's say, function app or Azure web app getting data or modifying data from a platform as a service storage account. There are new role-based access control roles for this Azure Business Manager data pane. So we have a role called storage vault data contributor, which is a storage vault data administrator. We have a storage vault data writer, reader, etc. And we actually don't need to do anything else except click a button on the UI of the Azure portal and say, for my Azure data, turn on manage identity, give me an Azure AD object ID. It will automatically create ton of different service principals and whatnot, do the app registrations, we don't care. We just say this web app has what data reader access to this storage account. And that's it. Azure does everything for us. We don't need to, you can actually just remove existing authentication and authorization code for more app. Once we deploy it to that correct web app, everything just works. And if you are, because I know you are, still using those old keys, then audit this particular action, resource provider action, monitor storage accounts, list keys action. Either deny that altogether, deny that as a policy or as a blueprint policy when you set up everything, so that nobody can actually list those keys, or at least raise an alert so that you know when somebody actually lists those master keys for your storage. And yes, MSK gives us this please rotate your keys control there as well. Okay. And that brings me neatly to the next topic at hand, which is that people don't monitor or set up alerts at all. The insufficient is actually being very polite in here. So it's like this is the default. When you go ahead and click on any Azure service, because there are some costs involved in extra metrics and monitor and logs, people just skip them, or because they need to give a new heading or there's a new resource that they need to create, and they want to minimize what is being created at a single time. And then they forgot to get this when they copy the same environment, the staging, and so forth. So insufficient monitoring and alerting, we have a ton of more data available, more metrics and more information, more monitoring APIs available than we had previously. And the ones that we used to have don't work anymore. You can't just use Wireshark and monitor everything that's going on with our Azure functions, because it's not our virtual network. It's not our network at all. So how will we even do that? So we need to change a lot of those things that we can and we want to monitor. A lot of those stuff. The first one is the big one. The audit logs, which have been unfortunately renamed into activity logs, which don't seem important at all. We used to call them audit logs. The activity logs are actually the place where you can actually see who performed that storage account list keys action, who performed that Kubernetes cluster delete action. All of those, anything that I do in CLI, in Cloud Shell, on Portal, or any way on Azure, all of those things get actually recorded. And even in kind of diff log type of way recorded, so I can see the specific change feeds for everything that actually was changed in something called Azure activity logs. And the default retention time for those activity logs, which are the lowest level, the most important audit logs that people have on Azure, is 90 days. And please go ahead and think of any of those big breaches that you have heard or read about. They never say that the intruder was caught in the first 90 days. For Sony, it was like 500 plus days. There was target for 200 days and so forth. So you need to actually have these audit logs available for you for a longer period of time. It's a ticket box, but you have to do it. And there is some storage account costs related to it as well. But not as big as the cost of actually you getting caught of not actually doing your job and auditing what you are doing on Azure. Think of this as the video recording of your data center. That's the lowest level that you can have on Azure. But then for each specific Azure service, for Azure SQL, we have similarly just fill in the box. You can get SQL audit logs. If you are using if somehow you are thinking of building a web application that you're hosting on Azure, then you most likely have an Azure web app. You can actually create something called Azure Firewall or Azure Web Application Firewall, which is part of Application Gateway. It's essentially a Apache WatchSpark as a service. It actually scans incoming traffic against OWASP top 10 security lists. It's not great at customization. You might get some false positives if you are using like three different internal AD forest being passed on as something else. You might actually have some learning curve, but once you kind of skip ahead of that, it actually saves a lot of saves you paper actually kind of quite many times. But you do need to configure then your web application actually only allow that traffic coming to the web application firewall, so that actually makes it useful. Do enable the application inside smart alerts. There are machine learning alerts that are telling you that there's something different, something has changed about your essentially web server logs. I have a customer that actually had paid DDoS monitoring from an operator, from a telco, that didn't catch a DDoS attack, but actually application insight caught a DDoS attack, and they just dismissed it because they were paying for someone who was telling them that there's no attack. And they went down. So it's actually quite a good one. Please use it. Advanced threat protection, whatever is named advanced threat. They keep on renaming these, but both for Azure SQL and storage account, you have similar. In the box, you get these nice machine learning alerts about something bad happening on your environment. You can create your own activity log alerts, as I showed you specifically on those storage accounts. And if you are thinking of those outages that we most likely have next year as well, because there's a leap here coming again. So if you're thinking of those Azure outages, not just your outages, then you should also enable these service health alerts that are actually sending you information when Azure is telling you. Pretty useful. Ton of HDSK control IDs available for that one as well. Don't worry, you will get the slide as well on this. Couple of examples. Those storage account smart alerts for the application advanced threat protection alerts can be something like this. Anonymous access suddenly happening in my storage account. somebody unexpectedly deleted it when typically we just add data. Now somebody actually access from an unusual location. Everything else checks fine, everything else is okay, you have right credentials, but from somewhere we didn't expect. Here's an example. This is from a real case from this April. My customer's software development team got an alert once I made them turn this on. The very next day they got this alert, and then they called me and essentially they were telling me that there's nobody from their team who is working from Kuusankoski, Finland. And if you think Finland is in the middle of nowhere, then you just wait, and then you go even further and even more further. And when you don't even see moose, and you don't even see reindeer anymore, then you have arrived at Kuusankoski, Finland, where apparently some of the teams, one of the team's developers has been actually working from remotely without telling the other members of the team. So yes, if you do recommend this to your team, and if you do this remote working without telling anybody, then be aware. All right, another one from this app insight. App insight is actually just listening to your IIS logs. So it's actually just it doesn't know about your app. You can teach it about your application. You can integrate it with your instrument in your code, but you can also just turn it on any running web application, and it creates these automatic alerts on changes in your web application logs. And in this case, we actually get response time degradation. So something is going slower than usual in get campaign index. That seems important, whatever the campaign index is. We'll see that this is 1,000% slower than normal response time. So this may be something that we want to look at, and then there's some more information saying that only 14% of all of the requests are actually performing slowly. So this is not maybe an attack, I don't know, but this might be actually a bug in our code. That's maybe interesting. And then here's an example of those service health alerts. Here we had an alert about Azure network going down, and if the network is down, then you most likely won't be able to go to portal.azure.com to actually find out about it. So you might want to get an email alert, or you might want to actually get this type of alert pushed into your instant messaging chat room of your team. Maybe your ops people need to hear about it. We don't do this anymore because once we turn this on and actually got a support ticket from each of those, well, things got a little bit spammy. So we kind of do a little bit of scraping data first. The nice thing is that you can actually just without any kind of custom configuration, you can actually get these alerts into your mobile app. So please do this when you are sitting waiting for the next metro. Yes. Yes. This is definitely a custom. This is definitely a real example because first of all, this typo, this is definitely me, so there is not storage keys that are being listed, and yeah, I guess the proofreader got fired. So yeah, you get these alerts into your smartphone. It actually sends those alerts to that person's smartphone where you have logged in with that user account. So it can be your colleague as well, if they've logged into the app. All right, very quickly for the last one, over on my time, but I'm having fun, so it's okay. Which is the platform as a service storage part. I did mention the network controls at the beginning, but let's kind of take on that one. There is something called a firewall for your storage layer, storage services, or Cosmos for storage account, for SQL database, for all of these places where we actually don't put them inside a virtual network. We do have this kind of allow and deny list of either virtual networks or individual IP addresses available. And if you are still, if you need to, for example, sell, let's say you are selling some IP jobs, you are selling maybe some media data to somebody who needs to download it, then you can't use managed identity to give a customer's iPhone managed identity and grant access to your blog. You still need to have some of those keys, but don't give them the master key. Create them a short-time SS token, shared access signature, that is only available for a period of time. That is something that has been available for about 10 years, and has been available. But nowadays, we also have, this is something that I don't see often used, we also have this firewall capability or IP whitelisting capability for SS token as well. So when somebody buys, let's say, a video file from my Mete app, I will send them a link to my storage account using this SS token that is only valid for, let's say, half an hour. And I will also use their client IP address and implement IP whitelisting for only that client. So only that client is available to download my file, and only the specified amount of time that I allow them to. There's a bunch of HSSK control accounts. This is actually how it looks. So I'll just go ahead with my storage account. I go ahead and go to firewalls and virtual networks. Sorry for that string. So I go ahead and go to firewalls and virtual networks. I click on the play, whichever. By default, allow access from all networks. I just tap on selected networks, and then I can go ahead and select a VNet or actually subnet of VNet that I have all access to. And on top of that, I can actually create a list of IP addresses that can actually despite those VNet rules. These are kind of independent, even though the firewall is kind of looks like it's kind of sub because it's not molded, it's kind of under the virtual network, it is molded. Actually, it's under the virtual networks part, which is they are the same level in here. So these are kind of, I can have here IP addresses that are not part of those virtual networks, and both of them together are kind of the combined list of allowed users. And then we have here the creation of the shared access signature. Short-term use storage account URL. Here I can select specific permissions, just read only for my user who is buying my data. I don't want them to delete the data or list any other data, and then I can go ahead and select those IP addresses there. Secure DevOps Kit for Azure is the one I've been referencing to from time to time over here. It is really one of the least known Azure security tools that I fully recommend you to have a look at. You can also have a look at that. You go ahead and download my slides. And generally, Carl slides. You will have that link at net. If you want to learn more about specifically that, you can look at my last year's Ignite talk. 20 minutes only about and then there's relatively new white paper developing secure Azure by the ARM team. All right. Thank you. Any questions?
Any questions, guys? No? Okay. All right, so let me just close out the event. Thank you for your great session.
You just unmute. Yeah, this is unmuted. All right, so thank you for the two speakers. Even though Mete is already left, please give them big applause again. The one thing I noticed this time, Azure security is very, very difficult, but interesting. So whenever we have question about the Azure security, we go into the Azure company, right?
Sure.
That's the Azure, right?
Sure.
Azure company. All right, so this is the page I was talking about at the beginning. This is Inspire. So if you go to the Bing or Google, just try to find Microsoft Ignite, Inspire, and there is a core node. And just 2 days after this event, we had Microsoft Business Application Summit. I watched this video just a week ago, and it was very impressive. If you don't know Dynamics, Dynamics is one of the cloud service Microsoft offer, Azure and Office 365 and the Dynamics. So if you think about the sales amount of the and money, Office 365, Azure, Dynamics, something like that before. But this year, actually, Dynamics is coming up. So many things, and we are consolidating so many Dynamics applications into one Dynamics 365 solution. So now we have 365 solutions: Dynamics 365, Office 365, and Microsoft 365, which is Windows 10 and the enterprise mobility solution, right? So everything going cloud, but we're still supporting the hybrid cloud, meaning if your customer is enterprise and if your customer is still running on-premise, and if they have a private cloud, that's totally fine, because Microsoft is one of the very rare companies supporting both cloud and on-premise hybrid. So if you have an enterprise customer, please reach out to us so that we can help to make sure everything running fine, both in on-premise and on private. All right, so that's it for today. And for the next meetup, because this was our first time to combine the event, I think it's time to say goodbye to each other. So we go back to the normal rhythm. So on the next event, September 17th, is a .NET Developer Meetup. So if you're coming from the Azure side, but still interested in some .NET developers things, please come. And on the 19th September, we are planning to the Azure Meetup. And if you're coming from .NET, if you're still interested in Azure, please come, because it's on the same week, Tuesday and Thursday, right? Another community, we need speakers. You can be speaker, your friend can be speaker, and you can requesting speakers to be a speakers. So just help each other, because I cannot be a speaker forever, right? And we really need somebody to present your content. And that content doesn't have to be the hyper grade, the awesome, the expert level. You can present something very beginner, because any content is appreciated anyway, right? Because we have some beginners, we have some the experts, but the other community, we want to help each other, right? So please do not hesitate to share what you learned, what you know. And if you already know something outside of the Microsoft world, do not matter, because this is a community. Just try to present whatever you want. And if you're not quite sure, let me know so that I can do the review together. I don't mind doing the rehearsal as well, right? All right, so that is for today. And thanks for coming, and see you next month.